Good morning. I welcome all of you to Degree Calculations 8th episode. Last episode, when I was doing last episode 7th, we were studying about one job's different types of development. This job actually it is having the shape of a oval shaped job. It is the plan. Actually I haven't drawn its elevation here because I am just teaching you only. So I have made some rough sketches only, but when you draw it to your notebook, you have to draw this all according to its proper scale. Actually here it is having the scales of 700 mm straight length from here to here, and there is a curve comes, half round comes, its radius is 600. Check that radius is outside radius and its thickness is 20 mm. It's a plan only, but how much of height it will be having? If we have to recognize its height, there should be one elevation. Elevation means front view, but I didn't draw elevation. Instead of that, I have just written a word height 2000 because I am just teaching you only. If I draw all elevations, all plans, I will be losing a lot of time, a lot of place also will be lost. So remember, it's elevation I had to draw here. If I had drawn elevation here, I would have written this 2000. That measurement I would have written there. Okay. So when you draw according to scale, you may not be able to draw 2000 mm because it is so length. So you can divide it with 10 or 100 or whatever you would like to prefer. Those measurements you can use and you can divide it and you can draw it to your notebook. If you divide it with 10, this 2000 will become 200. You can draw 200 to a big notebook. Big notebook you have to have because for drawing pattern developments, congested pattern developments are coming in my coming episodes. So you have to use one big notebook. So instead of 2000, if we divide it with 10, it will become 200. If we use the measurement 200 instead of 2000, you will have to use 70 instead of 700. You will have to use 60 instead of 600. You will have to use 2 instead of 20. Okay. As a conclusion, last episode we told about one pattern development. We had drawn 5 pattern developments and we had discussed about its goodnesses and also faults. Some good things may be with some developments, some bad things also may be there. Everything is having goodnesses and faults. Finally we took one decision. If you make this kind of one development, it will be good. Last measurement time, last episode time, we had taken its measurement, this rolling measurement. From here to here we have to roll. That measurement is 1853.5. I have written it here. According to the formula of pi d into degree divided by 360, we got this measurement last episode time. So this 1853.5 is the distance of rolling. It means from here to here we have to roll. From here to here we shouldn't roll. Instead of that, it should be straight. I have written here S. S means straight. R means rolling. In this area, we have to roll. In this area, we shouldn't roll. Instead of that, it should be kept as straight. This straight length is from here to here is 700. I have written it here. I didn't write it according to the laws and principles of engineering drawing. It is rough sketch only. I made handmade sketches only because I am just teaching you. But when you draw it, you have to draw it with proper scale. It means you have to use proper measurements with instruments of engineering instruments, scale, protractor, set square, compass, divider, these things, eraser, these all things have to be used. Okay, finally we got this development and we told if we use this development, we can make a good this kind of one job. This kind of two plates have to be cut. If we cut one plate, we can use it from here to here and here also. When it reaches here, from here to here, one development is coming, and one more development we have to use, one more plate we have to cut. That plate starts from here and it ends here. In first portion, one rolled portion is there and one straight portion is there. One rolled portion is there and one straight portion is there. One rolled portion is there and one straight portion is there. In second plate also, same thing have to be there. Same things have to be there. Rolling portion has to be there. Straight portion has to be there. This kind of rolling portion, one more we need. This kind of straight portion, one more we need. If we have got it, we can add here. From here, we can join. One half round will come here and one straight portion will come here. When we tack this one, after stacking, we can weld and we can make a job, this kind of one job. For making this kind of job, we will have to weld it. For welding, it has to have bevel. It has to have proper V. Otherwise, welding won't have proper strength. Welding won't have penetration. For that purpose, we have to use bevel. I have slightly shown here the shape of bevel. In this bevel, both sides it is having V. Both sides it is having bevel. What is its detail? Same drawing I have written here. Both are same. But here I have written one half round and I made this kind of one sign and I have written here A. It means this much of portion is having a lot of measurements. Its length, width, degree, that kind of details will be written in other place. I have to check, we have to check that area. That will be called detail A. So, in this drawing, we have to find out the area of detail A. This is detail A. This portion, this small portion, it starts from here, it is going to here, it is going to here, and it ends here. This portion, it is having so many measurements, so many details. Those details I have indicated here. Same thing is there. So many details are, means when this portion is welded with another portion will come here. Its one end has been shown here. It is the end of one plate. It is the one end of one pattern development. It is the end of one pattern development. Here we can see one straight line as a horizontal line. Here also we can see one straight line as a horizontal line. This line we couldn't see here because it is a small picture. It's a big picture. It has been zoomed and I have drawn here. But here I didn't write measurements because if I write it here, I may not be able to teach you. I have written these measurements here. Both are same. It is detail A, it is also detail A. Actually, it is proper detail A. It is having measurements. Some more measurements I had to add. How much of measurements I have added? One plate reaches here and ends here. Another plate ends here. In between there is a gap. Why do we give gap? We have to weld there. When we weld, it has to have proper penetration. For that purpose, we give welding gap. How much of welding gap we have to give? Each and every welding will have special specification. In that specification, welding engineer will have indicated how much of gap has to give. Somebody may say it has to be 4 mm because it is 20 mm plate. Somebody may say it may not be proper, it has to have some more gap, 5 mm or more than 5 mm, somebody may say. In some building in specification, no need of, somebody may say, it may no need of 4 mm gap, 3 mm gap may be enough for that. Or sometimes less than 3 mm also may be enough for some plates, some jobs, if it doesn't need more strength. Now I have written only 4. Now I am just teaching you, so I just wrote one number 4. And what is the length from here to here? Actually, when we see this one, we will feel as it is like a end of knife. It is a sharpened one. Actually, it is a sharpened one. When we look at its detail here, when we look at its detail A, we could understand it is not having a sharpened face. It is having a width. Its width is 1.5. There is enough place to indicate this measurement, so I indicated it here, 1.5. Actually, according to engineering drawing measurements indication, I have given gap here from here to here, slight gap here I have given. Everything I have given using my hand sketch only. Afterwards I have indicated using proper arrows. In between these arrows, gap is 1.5. It means from here to here is 1.5. It's a parallel two lines how we have drawn for showing the measurements. Okay. So, and one more thing we can see in this detail. One indication is here. It starts from here and reaches here. It is like a S type one indication. That indication can be seen here also. It starts from here, it ends here. What does it mean? It means this plate, this 20 mm plate starts from here, but it doesn't end here. It is having more length. It is going more and more length. But we can't indicate those all drawings in this paper or in this whiteboard. There isn't enough place. So we draw this much only from here to here only. But it continues here. This indication means this job doesn't finish here, it continues here. This indication means this job starts from here, but it doesn't stop here, it continues from here. It is having more length. From here to here, more lengths are coming. 700, afterwards rolling comes. This all we can indicate, so we used this indication. This indication means this job doesn't finish here, this job again continues. Okay. So we recognized for making this kind of one job, we have to use this kind of one pattern development. Finally, we decided. We had told about 5 types of pattern development. One development was small pieces, means one small piece from here to here, 700 bits, one small piece was there. That kind of one more piece was there. Here also one 700 piece comes. That kind of two plates we were cutting. That kind of one development we have made. And third development is from here to here. One half from this there. That is also a separate. And fourth is another rolling portion. That is also a half round. Starts from here and it ends here. It means total 4 piece. One piece, second piece, third piece, and fourth piece. That kind of one development we have made. Its goodnesses we have told, its faults also we have told. Another one development was with one job, only one plate. It means it starts from here, it doesn't end here, it again continues, it doesn't finish here, again it continues, it doesn't finish here, again it continues, and finally it reaches here and it ends here. It means it starts from here, make one full rotation and reaches here. That kind of one development also we have made. But everything had its own goodnesses and faults. Finally, we took one decision. This kind of one development we have to take. If we take this kind of one development, it will be useful for everybody. When we make this one job with this kind of one development, it will have more accuracy, more finishing, more speed, and material also won't be lost. That kind of thoughts we have made. So how much of length and width we have to take for making this kind of development? Total measurement, how much is total measurement from here to here? It is 1853.5 plus 700. These two has to be added. How much is that? Just to calculate, then you will get this measurement 2553.5. It means from here to here is 2553.5. For making that kind of job, 2553.5 lengths and 2000 widths, two pieces we have to cut. In that two pieces, from here to here we have to roll, and here to here we shouldn't roll. It should be straight. What is this 2000? 2000 is height. I didn't indicate it using one elevation, but its height is 2000. So we have taken one measurement 2553.5 into 2000. Then we can make this job. Can we make? No. If we make with this measurement, what will happen? One plate we will roll like this. Another plate also we will roll like this, and we will keep it in opposite way. When we keep it here, what will happen? In between the second portion there should be 4 mm gap. When we roll this one, after rolling, when we set it in a platform, there won't be 4 mm gap because we didn't decrease 4 mm. From the center of this gap to the starting point of this plate, we had to remove 2 mm. And from the center of this gap to the starting of this plate, we had to decrease 2 mm. We forgot it. It means when we make this job, it's one side. We have to remove 2 mm. We have to remove 2 mm here also. Otherwise, after rolling, we had to gas cut it. Otherwise, we had to grind it. It will become as a double work. It will become as a rework. If you do that kind of one work, you won't be a good fabricator. You won't be a good fabrication supervisor. You won't be a good fabrication engineer. So, before starting a work, you have to take its proper development. Actually, we thought it may be proper development. Both are same. These two measurements have been added, and we have done it. We thought it was the proper measurement. What is its problem? We forgot to decrease 2 mm from here and 2 mm from here also. Total 4 mm we didn't decrease. So we shouldn't use 2553.5. From this 2553.5, we have to decrease 4 mm. If we decrease 4 mm, it will become 2549.5. You just calculate and check it. If we use this measurement 2549.5 into 2000, and if we roll from here to here, and if we leave rolling from here to here, we will get one job like this. This job, if we keep it in a platform and if we start to weld, there will be 4 mm gap will come, because from this jobs 2 mm we have decreased here, 2 mm we have decreased here, total 4 mm we have decreased here. So we will get 4 mm gap here. It means we will get 4 mm gap here, we will get 4 mm gap here. So this is the actual development. We shouldn't use it. If we have used it, after rolling we will have to gasket it or we will have to grind it. It will become as a double work. We will lose money, we will lose time, we will lose a lot of things. Gasketing, if we do one more gasketing, it's acetylene charge, oxygen charge, labor charge, everything will be lost. If we grind it, we will lose the time, labor charge we will be losing, we will use the money of current, we will lose grinding discs, cutting discs. That kind of problem will happen. So when we take the development, we should use this. We will have to decrease 2553.5. From 2553.5 we have to decrease 4, then this 2549.5. In this 2549.5, if we have decreased this measurement to 4 mm and it has reached here, why didn't we remove from 2000? We didn't decrease 4. Why? One welding doesn't come here. In this portion we don't weld. It has to be indicated in this drawing. In this portion we don't weld. It has to be indicated in this drawing. It is plan only. I didn't draw its front view elevation, but for teaching you I shall just make a small elevation here. Actually elevation had to be drawn here. I shall draw small elevation here. There is enough place. I shall draw one small elevation, then you will recognize. Actually everybody, the person you are hearing me in the persons in my viewers, most of them know about my this elevation, and it's a top side, there is no welding comes, but somebody may not be able to understand. So I make a small elevation here. Its elevation I have been indicating here. There should be one dotted line. How much is the distance from this dotted line to this thick line? It will be 20 mm by its thickness is 20 mm. This dotted line, I have told you about this dotted line. Again, I don't explain it. And what is this height from here to here? How much? It is 2000. In these jobs, top side there is no welding comes. In its top side nothing is coming. It has to be indicated in this drawing. Its bottom side there is no welding, nothing comes. So there is no need for us to make one bevel there. There is no need for us to make a gap there. So 2000 will be 2000 itself. So I have indicated 2000 here. It doesn't have any change. So we are going to make one job, this kind of one job we are going to make using this measurement 2553.5 549.5 into 2000. We will mark this one in a plate. Actually, if it is a big plate, if it is only one plate, if we are cutting only one plate from that big plate, mostly we will be using gas cutting. Sometimes it may be plasma cutting. It is having 20 mm thickness. So we will be using gas cutting or plasma cutting. When we